All right. Well, thanks for coming or staying for Taste the Power of Drupal Plugins. So this is going to be a kind of a dive intended for developers into the plugin system. So especially useful if you haven't already started implementing your own custom plugins, but hopefully useful for anyone, even if you're already using it. We'll give you some ideas. So this is just, well, step back, this is the agenda, right? So you probably already know who I am. We'll spend some while just on the basics of plugins, talk about plugin managers, plugin discovery, plugin derivatives, config entities and how they interact with plugins, some starting places where you, in your own custom code or projects, probably would be the first places you'd implement a plugin, and then some considerations if you want to define your own types of plugins, which is a much more advanced topic. Okay. So this is me, that's kind of what I look like. I've done lots of stuff. I'm one of the organizers of the camp here. Thank you for attending. And I work for a small company in the Boston area now called SciSure. We do a web application for laboratory safety and compliance based on Drupal. Okay, so let's dive in here. So plugins encapsulate reusable functionality inside a class that implements a specific interface. So again, this is all programming talk. Plugins of the same type can be thought of different ways to satisfy the same needs. So a really simple example is the views module, right? There's different ways you could format a single row of data, and those are different formatting plugins. Or you can imagine different ways to fetch some kind of remote data. Again, those would be plugins. They have the same interface, but they're fetching different data. Plugins are provided by modules to extend Drupal, and this kind of the plugins are used when either you as a developer or you as the end user can pick essentially your strategy or the solution you need for a particular problem. So views is a great example. You can configure a view, say, how do I want this row to be formatted? That's you picking from the possible plugins to format that row. In other cases, it would be more done at a developer level, where there's maybe not a UI for this, but is equivalent that you go through and you pick what strategy, what solution do I want to this problem. This is an object-oriented design pattern called the plugin pattern. So Drupal, this is not like a Drupalism, this is a standard. If you go to a book on object-oriented programming, you would see this plugin pattern of design described. So then this is basically how Drupal has implemented that pattern. If you use older versions of Drupal, like Drupal 7 and before, you might remember hook block or hooks like that would let you find different implementations of different modules we're providing, right? And those weren't super flexible. You could only use one block in one place. The plugins are a lot more flexible. So one plugin can be reused many times, and you've seen this certainly with the block system since Drupal 8. I can now take the same block, the code of it is the block plugin, and I can use that many times on my site on different pages with different configurations. Right, so there's a lot more flexibility there. One module can provide many plugins, so it's not a one-to-one. So many plugins of the same type or many plugins of different types. So, and again, one plugin can be used multiple times in different contexts. There's also, we'll come back to it at the end, there's an alter hook involved here. So you can also, if you need to, alter what's happening either by another module or by Drupal core. You can, take away options for plugins that you don't want to be there, or you could even substitute the class that's being used for a particular plugin if for some reason you needed to, because all that matters is the interface, right? So the interface is the set of methods the plugin must implement. As long as you match the same interface, you could substitute your own version of that plugin in, and no one would have to know, but now the behavior would be your custom behavior. Okay. So you've probably seen plugins referenced all over the place if you've ever looked at some kind of Drupal code. And here's a couple examples where plugins are referenced, but it's not immediately obvious that what we're talking about is plugins. So the first one is in this field storage config. The field storage config is saying, it says type image. Well, you don't know what that is, but actually what it is saying that we are using the field type with the ID image for this field. And so the example is over there on the right. And you can see that this is this PHP attribute on the class image item. And in that PHP attribute, you see is a list of constraints. Well, constraints, that doesn't say that they're plugins, but in fact they are plugins also. So we can follow along, and if we find it, we can see that we have constraints for each of those names. So the ID matches what's in that list of constraints. And again, they have their own class, and they have this PHP attribute telling us that it is a constraint plugin. So we'll come back to a couple more examples, but this is just kind of giving you an idea that a lot of times things you might not realize you've already seen in Drupal code are using the plugin system. Okay, so we mentioned here just that there is such a thing as plugin ID, right? Every plugin type has a manager. So the manager's job, it's a service, it's in the service container, and basically its job is just to say, given a plugin ID, give me the instantiated object, PHP object that is that plugin. So every plugin, again, has an ID. It may be in its definition. We'll come back to what plugin definitions look like. It can also be generated as a derivative. Plugin derivatives are a bit confusing. We'll talk about those more. But an important concept kind of to remember is if you have any single plugin ID, that will always map to the same PHP class. So there's like a one-to-one relationship. If you see an ID, in that previous case, the image ID for field type was the image item class. Always 100%, is never going to vary. And I keep mentioning this idea of plugin instance. The plugin instance is sort of more specific. So we have this class that could be used, but we now have to have a specific instance of the plugin, and that combines essentially the plugin ID that gives me the class and a set of configuration. And those two things together make a plugin instance that's actually being used. And a way to think about this, right, is going back to the block example. Your block is going to be maybe visible on certain pages in a certain region, maybe have a certain number of items listed, right? So it's that combination of the block plugin and those configuration values about which pages and how many items, right, make that one instance of the block that shows up on your page. Okay, so digging into the code a little bit here. This is the plugin manager. I said every plugin type has to have a plugin manager, and there's basically one method you probably care about, which is create instance. Oh, I should pause here and say the PDF of these slides is already posted on the session on the website, so if you want to download it now or download it afterwards, it's available. So create instance, again, takes a plugin ID and configuration. They said the combination of those things combined together gave you a plugin instance. And a simple example, and one of the first types of plugins I think you may often want to consider is a queue worker. So queue workers, the sort of default system that Drupal gives you is that when Drupal cron is invoked, as part of that process in the cron service, Drupal will look for queues and queue workers that need to process some data. So if you need something to happen essentially in the background, not in real time, but some data processing, some background updates to happen, using queues and queue workers is a great way to do that. You may have heard in Sean's talk about the art museum that they're using this basically to do their daily updates of the data. When it changes in their collection records, they then put things in the queue and process these off. So it doesn't happen in real time, but it gets done every day. So that, you have the fresh data for the next day. And so you see at the bottom line I have here highlighted is that create instance method of the plugin manager. It's the factory interface. In this case, these queue worker plugins don't have any configuration. So all they get is the plugin ID, and a special feature of queue workers is that the name of the queue and the name of the plugin have to be the same. And you see that's kind of implied by the variable names. So the queue worker get definitions is really iterating over the plugin IDs, but the code, whoever wrote this code was like, well, I know the plugin ID and the queue name must be the same. So I'm getting that from the queue factory as the queue name, and I'm getting it from the plugin manager as the plugin ID. So if you want to implement these, you just have to remember that those two things have to match exactly. And then, of course, the queue worker, as I said, the plugin itself has to have an interface, and the queue worker interface is very simple. has one method, process item, give me some data, and process it. Right, so this is actually, it's pretty easy to get started. And this is kind of how it's invoked in the cron service. You see the highlighted line here. We're looking first for, at the plugin definition, to see how much time I have to process. Looping over all the things I've found. I keep fetching items off the queue. As long as there's an item on the queue and I haven't run out of time, I call process item on the item's data. So pretty straightforward, and if that works, meaning there's no exception, then I delete the item off the queue and I'm done. So this is a really nice, a nice way to get data processing done, and again, like a nice introduction to plugins, right? Just looking at this, you have no idea, like, for different queues, what is that plugin doing? You have no idea. It can do any kind of processing you want, but it respects that simple interface, process item. Okay, so sort of the next step of this process, you might be thinking, well, how do I find the plugins? How does Drupal core and how does the plugin manager find the plugins that need to be run on cron in this case, or in other cases? And so the simple version is probably the one that you'll use if you go ahead and write any of these, and that's that you have to have define a PHP class. It has to have the right attribute, has to be in the right namespace relative to your module, and it has to have the right interface. So there's basically three things that have to match up. The plugin ID is an attribute argument, and we'll come back to what that means. They must always be present, but as I said, every plugin has to have an ID. You can just think of it as simple as that. And then the rest of the arguments in the attribute become the plugin definition. And the plugin definition, and this confused me, compared to configuration are very different. So the plugin definition is always the same. Every time I create a plugin instance, it gets the same definition, but it may have different configuration. So the definition is a constant. At a minimum, it's just the plugin ID is essentially the definition, but the configuration is different. Discovery is usually cached. So of course, if you're doing development work and you write a new plugin class, you will have to clear the cache in order for it to be discovered. So I've mentioned PHP attributes a few times here. This was still kind of felt a little not so familiar to me, even a year ago. But this has been a feature, the PHP language since PHP 8. And basically, an attribute is a kind of metadata that you can associate with a PHP class or a method or a function. And it's a actual feature of the PHP language versus being some kind of add-on. They use this funny format with a hash mark and square brackets. And what's also kind of interesting is that an attribute, in order to define an attribute, there's usually a class, PHP class of the same name. So it's both a metadata that decorates a class and itself is linked to a class. And you can pass arguments into attributes, and Drupal typically you use the named argument syntax when you're adding a plugin attribute, and you can see what that looks like here, right? ID : telephone. So that's the named arguments. What happens behind the scenes is these arguments are actually used as arguments for the constructor for the class that represents this attribute. So there's kind of behind the scenes, PHP is saying, well, not only are you getting this telephone item, but you're also getting a field type attribute that I've instantiated with the data that's here as these arguments. Right, so coming back to the example I keep hitting on of key workers, so I'm going to dive in now a little bit more to a specific example of a key worker, one that's pretty simple. So in this case, as I said, the attribute arguments provide the definition, and for queue workers, if you want them to run on cron, you have to include in the definition an argument that says how much time should I spend processing this queue on cron. And in this case, you see the highlighted line says I want to give it 60 seconds of time. Every time Drupal cron runs, allow this particular queue and queue worker to work for up to 60 seconds. So that's what that means, and I kind of mentioned this before, but I'll show you again the highlighted line, right? This is a little bit uncommon. Often the plugin definition is used only internally to the plugin. In this case, the cron service is using it also to figure out how long to give this in the loop. But so you can get the plugin definition. As I said, it's going to be the same for every queue worker with the same plugin ID will have the same plugin definition. And so, for this particular queue, they will all be the same. Okay, and I've, again, alluded to this several times. There's a distinction that confused me at first of definition versus configuration. And I'll kind of say this again, that the definition is constant, it's the same. Basically, the plugin ID is part of the definition. It's the same for a given plugin ID. The plugin definition will be the same every time. In contrast, the configuration can be completely different between two instances of the same plugin. So the configuration array could have very different data. Things like where do I place the block, which pages is it visible on, what region of the page would be examples. Okay. So coming back to talk a little bit more about discovery. So in addition to the method I've told you about, which is attribute, namespace, and interface, we also have YAML file discovery for plugins that's used in Drupal core, and I'll show you an example of that. You can also you can define your own mechanism if you want. You could use Drupal's hooks to define plugins if you wanted for discovery. You'll also see, if you look, you'll probably see cases where plugins are using annotations instead of attributes. And so they basically work the same. There's basically, that's backwards compatibility support for that is still there, but it's going to be removed. And I'll show you what that looks like. But for anything you write new, you should be using PHP attributes. And then again, discovery is the process by which derivatives are generated, and we'll come back to that again, but that's important also to try to wrap your head around. So the example I wanted to mention for YAML-based discovery, the most common examples you'll see are the different kinds of menu plugins, so local tasks, local actions, things like that. And so you see here two essentially plugin definitions in this YAML file. The top level key here gives you the plugin ID. And the YAML-based discovery is really used in cases where almost all the plugins use the same class. So if you've ever looked at local actions in more depth, they are plugins, but 95% of them use the same sort of basic class. But we have one here that uses a different class. So this menu link add, and this I just want to highlight because it's like this is kind of a fun example of the kind of thing you could get out of customizing the class. So it's a very simple code change, but very handy. And the reason this particular class is handy is it essentially copies the destination query string through to the link that it itself provides, which basically means I can go from someplace in Drupal, a link that has a destination query string that usually indicates like when you're done with the process, come back to this page or come back to the specified destination. Oftentimes you link to a form that way, you submit the form, then it redirects you to that destination. So this local action plugin will then essentially copy that destination through. So it lets you have essentially two steps. So I can go from the first link to an intermediate page. Then I can, again, follow the local action, maybe go to the actual form. When I submit the form, I go essentially 2 pages back to where I started or to wherever the original page wanted me to go as the destination. So again, it's just a handy trick here, but by default, this doesn't happen with most links. I already mentioned attributes versus annotations. So on the left, like Drupal 10 and 11, primarily using PHP attributes. Again, this is actual PHP code. Older versions of the plugin, older documentation, older articles, you'll see using annotations. Annotations are actually just specially formatted code comments. And then they have to be parsed by a separate parser and that information used in some way. And So there's a lot of advantages using like a native PHP feature. A simple one to think about is if you make a mistake in the way you write your attribute on the left, that's actually going to be a parse error in PHP. PHP will throw an error and say, you missed a comma where you needed a comma, or you missing a colon, something's wrong, this doesn't work. The one on the right is a code comment, right? So you can muck it up as badly as you want. PHP will still happily, define this class. And then later things may break when you're trying to discover the plugins that are defined this way. It might get skipped, and you wouldn't understand why your plugin is not being found. It's because you have some typo in your annotation, which is a code comment, right? And so there's nothing that's going to blatantly break. It's just not going to get processed correctly. So anyway, that's an advantage of the new system here. So the other bit I want to talk about with derivatives, with discovery, is derivatives, which are kind of like an enhancement on top of discovery. So plugin definition, can not only have a plugin ID, but can also reference a driver class. And a driver essentially generates many more plugins based on one plugin definition. So it's an enhancement on top of discovery. So I've found one, and now it can give me back as many more as it wants. So drivers implement this driver interface. You can go find them in core if you want. And typically, a derivative looks like a base ID, a colon, and some other ID that is the variant of that derivative. And a lot of times these derivatives are either per entity type or per entity bundle. And a great example of that is that if you think about the field UI, so if you enable field UI module, right, it has tabs on every bundle of every node type to manage fields. Well, those tabs, those local tasks, are plugins. And so what's actually happening behind the scenes is that there's a derivative. For every node bundle, there's a derivative plugin that represents the tab on the page for that particular bundle to manage fields. That sounds it's a little complicated for what the end result is, but it's I think a good example of using this. Another common example is migration destinations. So if you use the migration system, it automatically has a destination migration for every entity type. Well, those are derivatives, right? So it really just has one class that knows how to save an entity, and maybe there's some slight variation per entity type. So it automatically generates these derivatives. Same with entity reference selection plugins. So default comment is essentially a default plugin, but it's made available for the comment entity type. And then a block plugin for each views block display. We'll show you more about that. But so if you think about it, the views module only has one block plugin, but you can create as many views as you would like. And in each of those views, you could say, give me a block display. So what actually happens behind the scenes is then views generates a derivative for every view with a block display. It generates a derivative block plugin that handles that display. Okay. So what I found very confusing when I first learned about this was how configuration entities intersect with plugins. And we talked about configuration coming into plugins. We talked about the plugin manager factory interface, where it takes this array of configuration as one of the parameters to create a plugin instance. We haven't really talked yet about where that configuration comes from. So in most cases, it turns out that if there's data passed in as that configuration array, it is actually part of the data that is encapsulated in a configuration entity. And so because of that, and I showed you that actually in that first YAML example, right, that one of the most common places you see plugins reference is if you look at, for example, the YAML export of config entities, such as that field storage config entity. If you look at views config entity, migrate config entities, block config entities, right, they're referencing the plugin ID, and they also contain the configuration values that are needed to make that specific plugin instance. So the config entity says, here's the plugin ID to use, and here's the array of configuration that's needed to make that instance. And that, for me, initially was very confusing because I'd gotten my head wrapped around the definition, right, which is the same every time. And now we have this configuration also coming in from config entities. So to make it even more confusing, a single config entity can reference lots of different plugins. And you can imagine, as I said, with a view, right? A view can have multiple displays. It can have multiple blocks defined. So a single view can be referencing, multiple plugin instances, each of which have an array of data that's going to configure it. If you're looking through the definitions of different config entities, you'll see that this notion of a plugin collection is used consistently, even for ones that only have one plugin, just so that kind of the methods and interfaces stay the same. So anyway, these config entities commonly have a plugin collection, even in some places it's just a collection of one. And one of the key points, and it took me a long time to learn this, is that if you want to get access to a configured plugin, the easiest way to do that is to load the configuration entity that references that plugin, and then you can nicely ask the configuration entity with a method to give me the plugin instance with its configuration already loaded in there. And so I'll show you what that looks like in code. And this is actually way easier than trying to figure out how to put those two things together by hand. An example of how that looks, right? This is the YAML export of a block config entity. In this case, the key in the YAML is plugin, which is the plugin ID. So this is a little easier to find and identify as being a plugin ID. And then the data in this settings array is actually, confusingly, the configuration for the block plugin. So the values I've highlighted there are basically that's the array of data that's going to be passed in as configuration to the block instance. And as I said, the easiest way to get this configured block plugin is actually to load this configuration entity, which has its own ID, which is Olivero powered, in the case of the Olivero theme. So I ask the entity type manager to get the block configuration entity storage, load the Olivero powered block configuration entity, and then you see there that the entity itself has a method called getPlugin. And typically, there's typically one plugin that is like the most important one, and this method will give you the most important one. There's also another method to get the whole collection of plugins. But this is how you could get the configured block plugin corresponding, that is essentially configured by this configuration entity. And then the actual block plugin itself, right, is pretty simple. It doesn't have a lot of things to configure. Basically, the main thing is whether or not to display the label, which defaults to false. And I'm sure you've all seen this block, right? It just renders a link back to Drupal.org. But just pausing here, take a look at this and think about, okay, well, hey, if you want to start writing plugins, writing a custom block is a great way to start writing plugins. It's very simple. You only need to implement one or two methods, particularly the build method, which returns the render array, is the most important one to implement. And then you have to apply the right attributes and extend the block base class, and your block will work. So coming back to the slightly more complicated example, so I told you that the views module, right, has plugin derivatives for every views block display that you go ahead and create through the UI or however you want. And you can see the top arrow there is pointing out that the plugin ID there is sort of the base ID of views block, a colon, and then another string which references the sort of specific variant that this plugin instance is going to represent. And then, of course, you see the settings below that, which are actually the configuration values passed in the block. And then there's even another plugin reference down here, down below, which has to do with the visibility, and it's using the entity bundle :node plugin to control the visibility of the block. And that, again, is a derivative, right? So essentially, there's going to be a derivative for every entity type in the system. So it's entity type node, and then you see down there below, it lists the bundles this applies to. Okay. I better move on before I confuse myself. And we should have time for questions, so I will, of course, be happy to go back and answer questions. But if you want to start digging in and writing plugins of different types, a great place to start, which we talked about at the beginning, was processing data from a queue on cron. So we talked about that quite a bit. Initial section, defining a simple block, which we just talked about, like that powered by Drupal block. Look at that. You could look at that as an example, and implement something like that yourself. And something that I have needed to do frequently is implement a custom REST endpoint. So this is something you can get access to if you enable the core REST module. There's also a REST UI module, which I believe is contrib. It just makes your life a little bit easier. And so the plugin basically represents a REST endpoint, but you need a configuration entity to make it active. And the REST UI module will basically help you make that config entity. And I'm going to show you an example here of a very simple REST endpoint called the dblog resource. It's from core. At least when I grabbed it, it had some flaws, but it'll kind of give us the basic idea. So the main flaw is that it doesn't have good dependency injection. And I'll point that out to you. But here, right, so we have a plugin ID, which is dblog. The PHP attributes give us some important things, including the canonical path. That's basically the URL that you would call from your external code to access this REST endpoint. And so you see it's /dblog/ some ID. And you can imagine lots of different cases where you'd want something like this to work. Again, this isn't the way I would necessarily do it, but it's fine. A lot of times these IDs might be for entities, and you could get the entity automatically loaded for you. But in this case, it's just a database record ID. You see the problem with dependency injection here is it's calling database : get connection. So it's calling a global static method to get the database connection instead of having it injected as a dependency. So we'd rather have it injected as a dependency. Boo, but it's not that important. And it runs a database query and tries to find the matching record and returns you this resource response object wrapping the data of the record. And that's, so you see you don't actually have to do that much work here to fetch some data from Drupal and then return it as a REST response. And you might be wondering, like, how does the rest of this fit together? Well, so there's, as I said, you need a config entity to make this active. And this is what the REST UI module's interface looks like. See I've highlighted here, this watchdog database log. We can enable that. And that creates a config entity. By export that and look at it, you see the plugin ID it references is that dblog plugin ID, which was the thing in the attribute above the PHP class. And you see some other important things here. It supports the get method. And I should back up here and show you. This REST plugin has a method named get, G-E-T, and it supports the HTTP verb, G-E-T, right? So these two things, that's kind of how it plugs together typically, right? The name of the method on the class is the same as the name of the HTTP verb that is being served. You see it, and here we can just say it supports these two formats, JSON and XML. That's great. I don't have to do any extra work in my custom code to support multiple formats. And I can support multiple authentication types. Here is just cookie, meaning I'm logged into the website. But you can use other things. In particular, we often use JWT, which is a kind of a bearer token for API authentication. And just to show you what you get for free basically doing this, right? So I can render this response of a single watchdog message either in JSON or in XML just by changing the query string and depending on which format I'm asking for. So again, if you, for whatever reason, you needed it in XML for one use case and JSON for another, you get that for free. Okay, so if we want to fix this problem of the database not being correctly injected as a dependency, there's sort of a better way to do it than what that core one is doing, and that's to use the Container Factory plugin interface. And so, say most of the time when you're writing something, especially something like a REST resource, or in this case, a thumbnail downloader that needs to load entities based on IDs in the queue, you want to inject a dependency. You're going to want to use this Container Factory plugin interface, and this interface is pretty simple. Only has one method that you have to implement, which is the create method. The create method is a factory method that gives you back the instance of the plugin, and you see that the extra thing it gets is the service container. So the service container is the thing that lets you pull out dependencies and pass them into the constructor of your plugin, so it gets these dependencies properly injected. Dependency injection is useful for a lot of things, especially for testing. Also, if sometimes these definitions in the container can be changed. You may, in certain cases, want to, for example, in a local development environment, you might replace all the cache backends with a null cache, so nothing gets cached. So you wouldn't want to have to, be directly calling the cache service somewhere in your code. You'd rather have the caches injected or the loggers injected, right? So if those things get changed in the service container, you automatically pick up that change. Okay, so again, in this case, we're injecting the entity type manager, that line I've highlighted, into the thumbnail downloader, and that's this return new static. Basically, just says return a new instance of this current class, and we're adding this extra argument into the constructor, and the constructor looks the way you would expect it to look here. So it has this extra argument of entity type manager, which we store in a property, and then we go to do some work. When we're processing an item off the queue, the only thing that the queue item has is the entity ID. And so that's why we need this entity type manager. Entity type manager gives us the media storage. We use the media storage to load the ID of the item on the queue. So we could have actually just injected the media storage and made this a little simpler, maybe just a matter of personal taste. And then you see this queue worker is allowing the media item to essentially update its own queued thumbnail and resaving the media item after it updates its thumbnail. So essentially what the queue is doing is loading these media items up and having them do some processing and essentially save the entity in the background on cron. Okay, so again, you can see this is not a lot of custom code. But this could be very useful if you want something like this to happen in the background. Thumbnails to be updated, summaries to be updated, something to happen in the background. Doesn't need human intervention. Doesn't need to happen instantaneously. But should happen. Hey, I created a media item. At some point, it should get an updated thumbnail. Great, I'm going to process this on cron using a queue. And the great thing about queue processing, which Sean mentioned in his talk, is right, if the queue breaks, if one of these items fails, there's an exception, that's fine. Drupal will come back and reprocess things next time it runs cron. So you don't lose data. It's not like you're trying to process them all at once and it's an all or nothing. It's just one at a time. And if one of them fails, you come back and continue picking up where you left off the next time. Okay, so last topic quickly is defining your own plugins, really your own plugin types, and it's a pretty advanced use case. So if you're writing a contributed module, you're writing custom code for a web application, or really almost something more like a SaaS product, where you are deploying the same code base to multiple customers who might make different choices about what implementation they want. This would be a case where you might define your own plugin types. So just off the top of my head, some use cases are different ways to store or access secrets or credentials in the back end, common interfaces to different APIs with the same functionality. So you're deploying this platform for two different customers and they have different choices about which weather forecast service they want to use. You could implement that as two different plugins of the same type. Language translation could be a similar case. Chemical safety database search. This is an example that was near and dear to my heart. So we implemented this but we knew that our current provider might not keep providing this service for the long term, so we did this as a plugin. And when we needed to switch to a different provider, we could write a plugin that connected to a different backend provider, but we still had, basically none of our other code had to change to account for the fact that we changed, which provider was giving us those safety data sheets. And again, use cases like different ways to render rows in a data table. If you're not using views, but you had your own system for rendering data, you could think of using plugins as a way to control the formatting of each row. If you want to do this, this sort of, again, gets back to just the process of discovery, right? You need to define a new attribute that you're going to use to decorate your plugin classes. You need to decide what namespace your plugins will use. You need to decide and write the interface. You need to write the manager. You need to have in your module a service definition for the plugin manager so you can grab it as a service. And then, of course, you need to implement your plugin at least in an automated test, at the very least, so that you know that all these pieces fit together and work. And we can see basically all of this in an example of the plugin manager. The key worker manager is actually not a lot of code. It's mostly using the default plugin manager. But you see it specifying these things that I just was telling you about. So the subdirectory, which is the first argument of the constructor, is really also telling you what namespace the plugins have to be in because we're using PSR4 autoloading, right? So the directory path of the class has to basically map back to, or the namespace of the class and the directory where the code live have to align, right? That's how PSR4 works to find classes. We are telling here that there's a particular interface that has to be matched, and then a particular attribute name, particular attribute that has to be applied to this class. Again, so the namespace, the interface, and the attribute, all three of these things have to be right to discover your plugin. I told you there's caching, so you can decide for your manager which cache backend it's going to use. And then you get to define essentially an alter hook. So this alter info essentially says define hook q info alter. So if you can look at this, and then some module can implement hook q info alter, and it can alter the discovery. An example of that might be Drupal core or something is processing data on cron, and you don't want that to happen. You could implement this alter hook, and you could remove from the discovered plugins the one that you don't want to be processed, and change the discovery information before it's cached. So that's why this alter hook is useful. You could also, as I said, change the class of one of the plugins and just substitute a different class that behaves slightly differently if that's what you needed to make your site work. Okay, so we're pretty much at the end here. So hammering on this point, plugins of a given type have a specific interface, and a plugin instance is the combination of a specific plugin ID and a set of configuration. Plugins are provided by modules, and discovery is based on the namespace, specific interface, and a PHP attribute. Most plugins that need configuration get it from a config entity, and your hint for the day is if you need the configured plugin, load the config entity and ask it for the plugin, and that's kind of your shortcut rather than going the other way around. Again, these slides are already posted. Links here. Most important link is to the official documentation. There's a bunch of other posts here I'm linking to. Some of these are older than others. Again, most of these are pre-Drupal 10, so they show you plugin examples using annotations instead of attributes, but again, there's really a one-to-one mapping. And that's it. So we'll stop there and take any questions in the remaining couple minutes here.
My brain is full.
Good?
Good.
Ian's brain is full. Any other questions or comments? No? Okay. Well, thank you for coming. I'm available. I'll be at the after party. As I said, the slides are available. So please download those and come find me if you have any more thoughts.
Great.
Thanks.